Today we are focusing on writing equations in two variables. We will look at what the solutions of equations in two variables look like, and then we will also talk about the relationship between those two. Tomorrow we will focus on graphing these equations. So when we have an equation in two variables, you're going to see, here's an example, y equals 2x. There are two different variables here. So the first thing we're going to talk about is the solutions. So when we had equations in one variable, maybe it was just 6 equals 2x. Then we could figure out what x equals. Our solution was x equals, and then the value. The difference here is that now our solution has two values because there's two variables. So we're looking at ordered pairs. So if you recall, an ordered pair is always set up so we have x, comma, y enclosed in parentheses, just like this. So if we look at 3, 6, it's x, y. Okay, so this is saying if x equals 3 and y equals 6, does it satisfy this equation? Does it make it true? So we are going to rewrite the equation using substitution. We're going to use x equals 3 and y equals 6. So if y equals 6 and x equals 3, looks like this. So 6 equals 6, that is true. So to answer this, we would say 3, 6 is a solution. Okay, letter B, same thing, but we do have an extra step, y equals 4x minus 3. So we're going to rewrite the whole equation, and again, x, y for our ordered pairs. So if y is 12, I'll put that here. Okay, x is 4. So I rewrite the whole equation, but substitute those values in. And then I'm just going to simplify each step. So 12 equals, I'm going to do that multiplication first. Then I can subtract. 12 does not equal 13, so we would say 412 is not a solution. Okay, go ahead and pause your video and try 1 and 2 down here. Go ahead and go through those same steps. You have x, comma, y. Substitute those in and determine if it is a solution or not a solution. Okay, here's what we end up with. That first one is not a solution. The second one is. Okay, go ahead and turn your page. The next thing we're going to talk about is what's called independent variables and dependent variables. So they do, those two variables are connected. And we can think of this, the word dependent, if you think about, if you ever hear your parents talking about getting taxes done or tax season, they might refer to you as a dependent. You are what's called a dependent. And again, it's just like it sounds, because you depend on your parents. You depend on your guardian. You depend on your family for food, a place to live, clothing, transportation. So when we talk about the dependent variable, it depends on something else. Okay, so here's an example down here. The equation y equals 128 minus 8x. Okay, it gives the amount y in fluid ounces of milk remaining in a gallon jug after you pour x cups. So we have two variables. Y is the amount of milk remaining in a gallon of milk, and then x is how many cups you pour out. So I always think about this like with my kids at home, they drink a lot of milk. So I'm thinking about which depends on the other. Is the amount of milk we have left at the end of the day, does that depend on how much we pour out throughout the day? Or does how much milk we pour out depend on how much milk is left at the end of the day? Well, we have to pour the milk out first. So that's what this is all about. When it says identify the independent and dependent variables, we are literally thinking which one depends on the other. So we are going to write out a statement for independent versus dependent. So we could say the amount of milk remaining, which is y, depends on how much you pour, which was x. So if y depends on x, then y is our dependent and x is our independent. Okay, the next part of this question is asking how much milk remains in the jug after you pour 10 cups. So this is saying if x equals 10. So if x is 10, what's left over? What is y? So if we pour out 10 cups, how much is left? So we're going to use that equation that we were given, and we're going to substitute 10 in for x. Okay, so 8 times 10 is 80. Then I subtract those, and we get 48. Okay, so we're going to answer the question by restating the question and answer in a complete sentence. And the no naked numbers here, we're talking about the amount of milk, which is in fluid ounces. So we would say there are 48 fluid ounces remaining. All right, so down here, we have a similar setup. The equation is y equals 10x plus 25. And it says it represents the amount y in dollars in your savings account after x weeks. So you need to identify the independent and dependent variables. So that's your first step. So think about it. Does the amount of money in your savings account depend on how many weeks you save? Or does how many weeks you save depend on how much is in your savings account? Then your next step is to say how much is in your savings account if you save for 8 weeks. So then it's saying, okay, so if x equals 8, how much is in your account? So you'll use that equation and substitute that in there. Go ahead and pause your video and give that a try. Hey, here's what we end up with. So the amount of money in your savings account is going to depend on the number of weeks you save. So y is our dependent, x is our independent. You substituted those 8 weeks in there. There is $105 in your savings account after 8 weeks.